Hello everyone. Today I'm going to show you how to create a CLI To-Do app using Go. You will gain practical experience in working with flag arguments to parse command line inputs and handling JSON data for storing and reading your to-dos directly from a JSON file. I built an executable from the project. Now let's go through the app. We can get a list of all the available commands by typing /todo --help. Currently we don't have any to-dos. Let's start by adding some. For example, buy groceries, read a book, and the last one, work on Go project. To view all the to-dos we can use the list command. Let's say we have been buying groceries, so let's mark that as completed. We can do that by using the toggle command. Buy groceries is now marked as complete, and it also got a completed time. We can also update the to-do by using the edit command. So for example, let's say we want to update the read a book to buy a book. When using the edit command, you have to specify the ID. In this case, we want to update read a book. So the ID will be 1 semicolon the new title, buy a book. We can now see that the to-do has been updated to buy a book. The last command we're going to take a look at is the delete command. Let's say we change our mind and we don't actually want to buy a book. So we just delete that to-do. To-do, delete, and then the ID to delete, in this case, 1. And if we now list it again, we can see that the to-dos will be gone. Finally, all the changes we make are saved into a JSON file. This means your to-dos won't disappear when you close the terminal. Let's start building the application. Create a main.go file. Package.main. And we will also create the main function. Func main. For now, let's just print something. fmt print line inside main in to-do app. The next step will be to create our structure for the to-do. Let's do this by adding a new file called todo.go. todo.go. And inside here we will start by defining a to-do struct. Type to-do struct. It will have a title field, completed field, created at, and last completed at. As you can see, completed at is a pointer reference, and that's because it can be null. Next we will create our to-do slice. This will contain all our to-dos. So type to-dos to-do, like this. We also need to define what package this belongs to. Let's add it to the main package, package.main. And let's import the missing libraries. It should be capital letter. We are now going to implement all the methods. Let's start by creating the add method. So func to-dos add, and this will take a title string. Here we will be using the to-do struct. So to-do, so we set the title to the title argument. Completed is false, and completed at can be nil. Created at, we will set it to the current time. And as a last step, we will append the to-do to our to-do struct. To-dos equal append, and let's pass it our to-do. we are going to add a helper method. It's going to check if the provided index for operations like remove, edit, or toggle is valid. So func todos, and it takes the index, that's an int, and it can return an error. I forgot to write the name. It should be validate index. So first we will check if index is less than 0 or index is greater or equal to the length of the to-dos. In that case, what we want to do is return an error. So error is errors dot new, and here we will just say invalid index. Let's print that to the console. fmt print line error, and then we will just return the error. In case the index is valid, we will just return nil. Return nil. To-dos here should be capital letter, like this. The next method we will implement is the delete method. So func to-dos delete, and it takes the index to be deleted, index int, and this can return an error. So we assign t to the to-dos, and here we will use the method that we created earlier, validate index. If, and then we assign error to the result of the validate index method, t.validate index. If error is not nil, we will return it. Return error. And if no errors, we will assign the to-dos to a new value. To-dos equal, and we will use the append function. Append, and then we're going to say t brackets colon index, and we will then say t index plus 1 colon, and then 3 dots, 1, 2, 3, and return nil. So what we are doing here, we are splitting the list at the specified index. We then join the two sections before and after the index, which removes the item from the list. So basically what it does is take out the item that we want to delete and gives back a new list without that item. Let's see our to-do application in action. So open up main.go. In the main method, you can delete the print line and then assign to-dos to be of the type to-dos. So let's add some to-dos. To-dos, add by milk. To-dos, add by bread. And we can print the contents of the to-dos by using fmt printf. So in case you haven't used the printf method before, it allows you to print formatted data. This here will be replaced with to-dos, and then we just add \n to add some spacing. After that, let's delete the first to-do. So to-dos dot delete, and we will pass in the first index. So in this case it will be 0. And let's print out the to-dos again. So fmt printf percentage plus v, and then to-dos. Now let's try to run this and let's see the result. So open up your terminal, Let's create a module for our application. To do that, you can write go mod init and let's call it to-do. Alright, this now created up our module. Let's try to run our application. We can do this by writing go run dot slash. And in the first print statement, we can see our to-dos that we added: buy milk, buy bread, and then we delete the first to-do, which is buy milk, and only buy bread is left. So it seems to be working. Let's keep building the functionality of our to-dos. Let's add a method to toggle a to-do between complete and not complete. Go to your todo.go file. And here we will create a new method called toggle. So func to-dos toggle, and it takes the index of the to-do int, and it can also return error. We can copy some of the code from the delete method. So after we have validated that the index is good, we will have a isCompleted variable. So isCompleted, and we will assign it to our to-dos t, and then the index completed. If it's not completed, we will create a variable called completion time and assign it to time.now. And for our to-do t index completed at, we will set it to be completion time. And our completed at will take a reference, as we can see here. So we will get the reference of the completion time. We will then write t index.completed, assign it to opposite of isCompleted. So basically what we are doing here, we are flipping the value. If isCompleted is true, we will flip it to false, and if it false, we will flip it to true. As the last step, we will return nil. Return nil. Let's add an edit method. It will be similar to the toggle method, but a bit shorter. So we can copy this code and just paste it below. And basically what we can do is we remove this part, and instead of completed, we will update the title. So title, it should be equal to title. And then we will add a new argument. Title, it should be a string. And we will also change the name to edit. And that's it. So in this file we only have one method left, and that is to print the to-dos. We will use an external library for that. To install the library, open up a new terminal and then type go get github.com/aquasecurity/table. And then you will see it's being downloaded, and you can double check in your mod file and you will see that it's been added here. Let's implement the print method. Func, same as before, to-dos. And this one will take no arguments. So here we will use the library that we installed. So create a variable called table, and then assign it to table.new and pass in standard output os.st, and let's import the library. Add import, and we can now see it's being imported at the top. We will now start with configure our tables. The first setting is table.set row lines. We will set this value to false. There will be no horizontal lines between the rows. And we will also set up the headers. So table.set headers, pound symbol to show the ID. Then we have title, completed, created at, and completed at. The next step is to loop through all our to-dos. So we will do this by using a for loop. For index t as in to-do, and then set it to range to-dos. We will create two variables here. Completed. We will set this to a X emoji. And we will create a new variable, completed at. We will set it to an empty string. Next, we will check the to-do if it's completed. If t completed, we will change our completed variable to be a check mark instead. So completed equals, and open up the emoji picker here, check mark. All right. Then we will do a new check here. If t dot completed at, oh, I see I misspelled the variable, completed at. If t completed at is not equal to null, then we will set the completed at variable to be the value of t dot completed at. And we will call the format method. What we are doing here, we are basically formatting the completed at using this standard. The next step is to add all the rows to the table. We can do that by writing table dot add row, and now we should pass all the columns matching the headers. So the first value will be the ID, and currently is stored as a number, but is expected to be a string, so we will convert it. We can convert it by using this method. And then we pass the index. Next is the title, t.title, and then completed. And we will pass the completed variable here, completed. Then we have created at, and we will format it same as we did for the completed at time. So we can copy this. And we can change this one to t.created. Oh, one too much. Like this. And as the last step, we want to pass the completed at. Completed at. And the only thing that is left now is to print the table. And we can do that by using table.render. Let's try this out and see if it works. So open up the main.go file. And we can update this. So delete these lines. And let's say we also toggle a to-do. So todos.toggle, and let's say the first one. And now we can write todos.print. Open up your terminal and type go run. And as you can see, this seems to be working. However, let's make this a bit bigger. The problem is when we restart our application, all our to-dos are gone. It would be nice to have the functionality to read all our to-dos from a file and also to save it to a file. Let's implement that now. Create a new file called storage.go. Storage.go. And here we will be using generics from Go. And basically what that means is that our storage file will work with any type, not just the to-do type. So let's start by creating a storage type. Type storage. And it can be of T, that is any, and it will have a property file name that will be a string. Let's not forget to add a package.main. Also have to add a struct keyword. Yep. And for this we will create like a constructor. We will do this by writing func new storage t any file name. That will be a string, and it will return a reference to storage with the type t. Return storage t file name and set that to be file name. Oh, my bad, it should be a big T here. So in case you're confused what this T mean, it basically mean like when we're calling new storage, it will be a storage type of the type we provided. So if we call new storage with our to-do type, we will get back a storage type of to-do type. If we would use like a, I don't know, like a JSON type, and we call new storage, we would get back a storage with a JSON type. So T is basically just a placeholder for the type you pass in. And our storage type, it will have two methods, save and load. Let's start implement the save method. So func storage t save. It will take a data and the type will be t, and it can return an error. Here we will convert our data into JSON, so we can do that by writing file data error and assign it to using the JSON.Marshall indent, and then we pass the data that we want to convert to JSON. We don't care about the prefix, we leave it as an empty string. But when we're converting our data into JSON, we want to have some nice indentation, and we can do that by having a string with 4 spaces. 1, 2, 3, 4. After that, we will check if there's an error, if error not equal to nil. If it's not nil, return the error. And now we will write this JSON data to the desk. We can do that by writing, let's see, return os dot write file. Here we need to specify the file name, and we can get the file name from our storage type. So s dot file name, and then we have to pass in the data we want to save, that file data, and as the last argument is what kind of permission should the file have. In case you wonder what this permission means, so it means that the owner can read and write to the file, the group members can read to the file, and everyone else can read to the file. Now we have to implement the load method. So let's see, func storage load data type t, and it can return an error. So we will declare file data error, and then we will use os.read file and provide the file, and this we have in the storage. So s.filename if error not equal to nil, we return the error, else we will use the JSON.unMarshall. So we pass file data. Let's not forget to return it. The unMarshall method, it will convert the JSON data and populate this data argument that we pass here. Let's update the save method to have capital case. In this case, it doesn't really matter because we're only using package.main. But if this would live in another package, only methods with capital case will get exported. Let's try it out. So open up your main.go file. After to-dos, we will create a new storage, and then set it to new storage. And because we are using generics here, so we have to specify what type it is, and it's to-dos. And then we pass our file name. We will call it todos.json, todos.json, and then we will use storage.load and pass the reference to our to-dos, so it will get populated. After the print method, let's save the to-dos. We can do that by writing storage.save to-dos. Now let's try to run the program again. So open up your terminal, go run. So the result is same as before, but as see now the todos.json have been created, and if we inspect it, our to-dos that we created up will be inside here. Let's go back to our main.go. If we now remove these ones and we try to run the program again, it should read from the JSON file and print it out. And it worked. The only part that is missing now from our application is to be able to pass different commands from the terminal. So let's implement that now. Create a new file called command.go. Command.go. We will set the package to be main. We will create a struct with all the available commands. Type, and we will call it command flags, struct, add. This will be of type string. Then we have delete, and that will be of type int. Edit be string, toggle will be int, and the list, that will be a boolean, list bool. The next step will be to initialize all the commands. So we can do that by writing a new function, new command flags. And this will return a reference to the command flag struct. We set cf command flags, flag string var. Here we will pass the reference to the add field. .add. The next argument is specifying what's the name of the command, and it will be called add. There will be no default value, so we set it just to an empty string. And then the last argument is a description that will show up when you type help, as I demonstrated previous in the video. Add a new to-do, specify title, and we can copy this line and do the same for edit. No default value. Edit a to-do by index and specify a new title, id : new title. And the next command is for the delete, so instead of it being a string var, it will be int var. Delete. And we can set the default value to be -1. Specify to do by index to delete. We do the same for toggle. Call it toggle. And the default value will also be -1 here. Specify to do by index to toggle. The last command will be the list command. list, and it should be, instead of an int var, it will be a bool. We will call it list and default value false. List all to-dos. And now we need to parse all the arguments, so we can do that by writing flag dot parse. And now we have to return the reference to the command flags. So now we have initialized and set up all the commands. The next step is to execute them. We will do that by creating a new method. Func. It belongs to the command flag struct. We will call it execute. And as an argument, we will take the to-dos. And here we will use a switch statement. So we can do that by writing switch. Here we will add the different cases for all our command flags. We can start by the list case, cf.list. In case the user specified this command, what we want to do is print our to-dos. So to do that, we write to-dos dot print. Next, we add a case for the add argument. So in case the add argument is not empty string, we want to call to-do and supply the title. Next, we add a case for the edit. If it's not equal to an empty string, here we have to split the value that the user supplied. It will look something like this. First ID, then colon new title. To split that, we can get a new variable parts and set that equal to strings split n, pass the value, so cf.edit, and we want to split it on the colon, and we expect it to be 2 values. Here we can do some validation, so we can add a if statement. If the length of parts is not equal to 2, in that case we know that something went wrong and we can throw an error. So let's first print out error invalid format for edit. Please use ID colon new title. And then we can just do OS exit 1. What we want to do now is to get the index from the part slice, and we can do that by creating 2 new variables, index and then error. And here we will use like the string convert library, strconv. And this one has a method called atoi, ATOI. It stands for ASCII to integer. So basically convert a string to an integer. The index will be the first element in our slice. So we can write parts and then get it by index 0. If error is not equal to nil, we will print error invalid index for edit. And then we can just terminate os.exit 1. And if no error, we can just use the edit command. So todos, edit, and we supply the index. And then we will supply the new title that we can find in the second position of our part slides. So part index 1. And the next case will be for our toggle command. So if cf.toggle is not equal to -1, then we want to do todos.toggle and just pass the index that we want to toggle, and we get it from cf.toggle. The last command is for delete, so case cf.delete. If it's not equal to -1, we want to call todos.delete and pass the index, so cf.delete. And that's it. That's all our cases for all our commands. We can also add a default statement in case if there is no matches. So let's just print line invalid command. And all we have to do now is update our main.go to use the new command file. So after we have loaded the to-dos, we will create our new command flag. So command flags, and set it to be new command flags, and then we can call command flags dot execute, and we will pass the reference to our to-dos. So to-dos like that. We can remove this print line, and that's it. We can now try it out in the terminal. We can run go run / let's try the list command. List seems to be working. Let's try to add a new to-do. Add go for a walk. Let's try to list it again. Yeah, it seems to be working perfectly. Let's also try to edit it. Edit number 2. Go for a run. This has now been updated, and let's switch it to complete. Go run. Then we use the toggle command. Toggle number ID 2. That also works. And the last one, let's try to delete it. So delete to, okay, and we list it again. Perfect. We reached the end of this tutorial, where you learned how to build a CLI To-Do application in Go. Feel free to play around with the code and maybe try to add some new features. Thank you for joining me today, and I will see you in the next video.